This is the Loosely Coupled Show with Derek Comartin and James Hickey. This episode was recorded February 11th, 2020, with our guest, Steve Smith. Steve Smith is an entrepreneur and software developer with a passion for building quality software as effective as possible. He provides mentoring and training workshops for teams with a desire to improve. Steve has been recognized as a Microsoft MVP for over 10 consecutive years and as a frequent speaker at software developer conferences and events. You can connect with Steve at ourdallas.com.
All right. So thanks, Steve, for being on the Loosely Coupled show. This is our first recording. I think we're going to do an episode. Actually, we'll release one before this one, just kind of introducing what we want to do. Yeah. Wah, wah, wah. So yeah, our goal is really just to have like a conversation, not too formal or anything like that. And there's a list of questions that we have that we'll just go through them. We'll discuss. Ultimately, our audience, the audience we're shooting for, is kind of people who know architecture is important, but they still haven't kind of gotten into it. They're still learning kind of the fundamentals and things like that. So the first question I'll ask on the list here is, what is it? What is architecture? And maybe there's different points of view that you want to attack that, and we can talk about that.
So I think of software architecture as being design decisions that you make about your system that are not easy to change, and that's pretty much the short version, right?
Yeah.
Constantly when you're doing software development, you're making design decisions. Every function you write, every variable you name, but those are generally fairly easy to roll back. Architecture from design is how easy it is to make changes to those decisions, and so it's important that you get them right, because then they will allow you to adapt to new requirements or other changes that are required of your system in the future.
So so architecture itself, you would say those are the decisions that are hard to change. Design, would you distinguish architecture from design? And design maybe is something else?
I think they're very closely related. I don't know
Okay.
if that view is shared by everyone, but I've heard it said, and I don't remember who said it, that the architecture is the design.
Mm-hmm.
Just as I've also heard that the source code is the design, right? So it's the manifestation of it, not whatever you put on the whiteboard or in some documentation. And so they're tightly coupled, right? Which is I guess the opposite of the podcast name, but the system and its architecture are tightly coupled. The design of the system can't escape from architectural decisions that were made. Just like a building is totally going to be dependent upon its architecture. That's true of your software application as well. So it's sort of the fundamental underpinning of your software, and it informs or impacts any design decisions you're going to make about how you're going to build that system.
So would you say, I know from my experience, being a junior developer and even kind of into the intermediate stage, there's not as many opportunities to really get your hands dirty in, I'd say, maybe the high, the deeper end of architecture. Where would you draw the line? Like, obviously there is design and some architecture relating to maybe writing code at the class level. Should class A be responsible for these things, and how does that communicate with maybe this other class? Obviously those are design considerations, but do you think that as someone's career kind of goes on, they kind of climb up to maybe like a, starting lower level, and then you kind of move up to maybe dealing with full applications, and then maybe full like systems?
Yeah, I think that's a fairly typical progression, is that you start as a developer and you're working with lower level pieces of code, and as you get more experience, you start to work at higher and higher levels of abstraction in larger and larger applications, if you choose to go that path, right? And so, I do see a lot of companies where if you just look at their org chart, or you look at their list of job titles and seniority, it's not unusual to see like junior developer, senior developer, managing developer, or something like that, and then architect, and then like senior architect, principal architect, right?
Yeah.
Or if you don't go that route, then you go into like project manager, program manager, product manager, something manager, and you tend to step more away from the technical side of the profession and more in the team and people and product management sides of the profession.
The one thing I've been seeing more of, I guess maybe lately in the last few years, is maybe this notion of there not being a designated role of architect, rather than it being more of a team-oriented concept or something that everybody maybe not equally is contributing to. That may kind of piggyback off what we're talking a little bit, is how much responsibility do people start taking on if there isn't a designated role where maybe, having a direct distinction between developer, people actually physically writing the code versus the separate architect.
Sure. And I've seen, depending on the company, depending on the team size, you can have any variation. You don't necessarily need someone with that job title to tell the developers how everything needs to be done or to start the project off. But certainly if you have a lot of more junior developers, it will help them to stay aligned with, how to write code in the way the organization thinks is the best way. If there is some guidance, right, from senior developers or even from an architect who can kind of lay out the bigger pieces of the system. Where I think it's most important is when there's multiple teams, and those teams need to ultimately build something that's cohesive and works, with one another's projects. That's where having, someone whose job is more at the strategic level and not at the tactical level becomes more and more critical.
So at that point, so I guess that kind of just reveals this relationship between the code you're writing and even the design that you have and the organization, the way the organization is structured also, right? So they kind of, there's this play between, okay, if you have two different teams and they're all coding into the same code base, that is quite different than having two different teams coding in their own separate databases that, however it happens, maybe they can communicate back and forth, whether it's like, through an API or whatever. I think that's where things kind of get hairy, I guess. A lot of people kind of fail to recognize that relationship and think it's all about the code and the technology.
Well, and there's Conways Law, which you two have probably heard of, but Conway's Law basically says that, software applications from a company tend to mirror the hierarchy, the org chart structure of the teams in that company, because that's, it's easier to do things in your own code than to talk to somebody on another team that might not even be in your same building or your same country. And so if you can solve something with your team locally, you will, and you'll put off or avoid doing things that require some other team. And so a lot of times you end up with teams each doing their own thing and doing it not quite the same. And then they build these silos that are entirely compatible. Whereas if you had fewer teams or if you organized the people differently, you might arrive at a different solution. And so like you were saying, the architect, I think, is one of the roles that can play a part in keeping multiple teams working in such a way that their code and the products of their code, integrate into something cohesive that's easier to maintain and easier for customers to use when all is said and done.
Yeah, I've just recently started reading Simon Brown's book. What is it? Architecture for Developers, I think it's called. And he, I think in the first chapter or so, he points out the difference between application architect, solution architect, and enterprise architect. I think kind of the big point he draws is the enterprise architect is all about people and organizing people. Basically kind of what you just said, right? Organizing teams and people in a way that they can do their own thing, communicate properly when they need to, as opposed to maybe like the solution or application architect. If I don't know if those distinctions are so helpful, but I think the distinction between those whatever, enterprise architects, if you want to call it that, who are dealing with people and managing teams versus, architecture in terms of I'm actually touching the code or I'm actually organizing, things that do affect the code. And I think,
And
go ahead.
go,
Sorry.
go on, you go ahead and finish.
I was going to say it's you had mentioned like there's kind of like this spectrum, right? It's not kind of like I'm an architect and this is exactly what I do. There's definitely this spectrum of, like Derek was saying, teams need to do architecture, individual developers need to do their design and architecture. So it's kind of this pervasive thing that kind of everyone does some part of it, which I think is why I know for myself when I started getting into it, it was kind of confusing. You just the terms themselves are very ambiguous. It doesn't seem like there's that much precision when you really get into it. And then we start throwing all these titles out, right? It's
right.
Kind of confuses people even more.
Yeah, I mean, there's some arguments, I think, about whether or not an architect should write code, for instance. Mm-hmm. And, I'm on the side of the argument that yes, you definitely should, write code, or at least be able to write code and understand code. Because if you only work in UML and drawing shapes and lines, then it's much harder for you to translate that into actual working software, which at the end of the day, someone has to do. So you better be sure that what you're drawing is actually something that is going to work, is my opinion.
That kind of, keep going, sorry. I was going to say it segues a little bit into should or do non-technical business people need to care about the architecture?
They definitely need to care about it because they're impacted by it. I don't know that they can say a whole lot about it necessarily, right? So they don't need to be in every meeting where it's being discussed. Perhaps beyond, like, they should make clear certain requirements as early as they can if they're going to impact the architecture. And that's a conundrum for them, right? Because they have no idea which things will or will not affect the architecture. There's a great XKCD comic from years ago where, I forget exactly what the example was, but it was like, the customer is like, okay, I need, this one feature where, I need to be able to read some text off of a piece of paper that the user scans in. And the developer's like, yeah, okay, I can use an off-the-shelf library to do that, and it'll take me about 4 hours, no problem. And then they're like, okay, now I need you to, like, be able to tell me when, the weather in this part of the world is this way or something. And they're like, okay, well, I'll need a team of 5 people and a couple $1 million of research for 10 years or something. It's like, the scope of the problem is like totally different. And in the XKCD example, which escapes me right now, it was 2 things that seemed relatively simple to the end user, right? They had no idea that they might require entirely different amounts of scope. So an example of that, to bring it back to architects, is if, for instance, the end user or the stakeholders expect at some point that this might be a multi-tenant system, like, that would be really nice to know up front. Because if you build a simple monolith with no anticipation that it's ever going to be a multi-tenant style of app, it'll be really difficult to add that on later than if you know up front that that's what's expected.
So what do you think are some things that enable good architecture? Like, what are enablers? Like, get you down the path of success rather than, like I said, there's some rigidness to the whole thing.
Mm-hmm. Like, well, what are some decisions that are hard to undo later, right? So to me, these are things like, what framework are we going to use? What language are we going to use? Those aren't exactly tied to architecture, but they're decisions that you make early on in a project's life that are really hard to change later. And then how are the different logical parts of the application going to be broken up? Are they going to be broken up? And if they are, what do their dependencies look like? How do they communicate with one another? How many things are we going to ship to run? Is it going to be a monolith where everything just runs in one process, possibly in one file, one DLL or one script? or is it going to be, many different things, like a microservices architecture or a SOA architecture where, we're going to deploy a whole lot of different things and they're going to, be orchestrated to work with one another, or they're going to, magically work with one another without some, centralized orchestrator involved. Those are all different ways to tackle, architecture of a system.
So, you deal with like helping teams, dev teams, probably in lots of different ways. But in terms of architecture, what have you found to be kind of the biggest blunders, or maybe the things that you've found people struggle with the most when kind of they're trying to learn and get into design and architecture to begin with?
So my customer base tends to be Microsoft developers and like
Okay.
.NET developers, and so most folks that were building stuff on .NET in the early part of the century, which sounds weird, but like when .NET first came out, for like the first 10 years, and it was web forms and WinForms and all that, almost everybody was building stuff using a very database central style, and so things tended to be very tightly coupled to whatever their database was. And over time, practices like continuous integration and automated testing, continuous delivery, and things like domain-driven design and microservices later on, have come along and have really gained a lot of traction, to the point where even Microsoft has rebuilt .NET from scratch as .NET Core and incorporated a lot of principles from many of these things. And so the common things that I have been teaching people about for the last 10 years or so have been dependencies and how to make your software less tightly coupled. Where does it make sense to introduce seams? Or a seam is something where we can break the code into multiple pieces and then isolate some piece and test it independently, or swap it out with a different version if that's what we want to do. Most code that was written by most Microsoft developers that I work with, and maybe that's self-selected because they're the ones that need my help, during that period, is very tightly coupled, right? It's very tightly coupled to the database. It's very tightly coupled to all the things that software does. There's not a lot of abstraction. And so code that I write today and that I help people write today, GitHub projects that I have that kind of help you get down the right path, like my clean architecture solution sample, make it so that a lot of those decisions are loosely coupled. The most important one being your coupling to infrastructure. That's not to say that you're necessarily going to change your database or how you send emails or which other services you work with. But if you don't tightly couple to them and instead you have an abstraction that you work with that you own, that will make it so that it's much, much easier for you to test your app and to change it later if you need to swap out a dependency.
So for someone who's just getting into this like design, and I mean dependencies, everyone has to deal with those, but as far as like tightly coupled code, do you have any heuristics or maybe like telltale signs when you're looking at maybe code that you can see, oh, this is tightly coupled, I should probably break this up somehow? Do you have any like
Sure.
guidelines or anything like that?
I think for object-oriented programs, right? So this doesn't necessarily hold true for JavaScript or Python, but for C# developers on .NET, I would strongly recommend that they look into Solid and the Solid principles, right? And I have a couple courses on Pluralsight about it, but you can learn about them for free elsewhere if you want. But learn about it to the point where you know it innately, not just that you watched a YouTube video on it once and you figure you've got it. Because if you follow those principles, they will tend to help you write loosely coupled software that follows the types of heuristics you're talking about. Okay, so let me go through Solid real fast and how it relates here. So sure. SRP means single responsibility. So your classes do one thing and they do one thing well. Now that means you're probably going to have fairly small classes because they only do one thing, which is great because they're simple. The skill you're going to have to develop, if you haven't already, is the ability to find things in a solution or in a software project that are broken up into lots of little files. If you're used to working on like a project where everything is in a couple files that are a few thousand lines long each, it's going to be a different kind of skill to be able to navigate around that code base. But once you develop that skill, you'll be fine. Then O is open-close principle. That says you should be able to change how a class behaves without having to actually change its source code. And when you first hear that, you might think, well, that's strange. How the heck would I change it without being able to change the source code? But we do that all the time. You just pass in a parameter, and then in that code, based on what parameter you pass it, you do something different. And if you use something like the strategy design pattern, you can actually pass in not just a literal, but you can pass in a whole object into this other class that totally changes how it behaves. And so that's what dependency injection is, essentially, is the strategy design pattern. Liskov is the L. It affects more things where you're doing polymorphism, and it'll help you, write bunches of objects that inherit from a certain interface or base class in a common way. It's probably less important than the other four for what we're talking about. Interface segregation is the I. That basically says you want to have small interfaces that are cohesive. They do one thing and do it well. It's kind of like single responsibility, but for interfaces. And then the D is dependency inversion principle. And that one is, I think, the most important. Sadly, it goes at the end because you couldn't make a nice word if you did it a different way. But it says that you shouldn't have your high-level modules, your business logic, depending on low-level details and low-level modules. And you should also not have instead it should depend on abstractions. And then your abstractions should not depend on details, but your details should depend on abstractions. So when you look at most of the code that was written 10 years ago, and a lot of code being written today, if it was broken up into layers at all, commonly those layers would be the presentation layer or UI layer, which would talk to a business rule layer, or business logic layer, and that would talk to a data access layer. And the dependencies flowed just like that, right? And so your business layer depended on the data access layer, and so you couldn't test it in isolation without the data access layer and probably a database. What the solid principles, and especially dependency inversion, suggest is that your data access layer and any other infrastructure, whether it's talking to a service or it's sending an email or talking to the file system, it should depend on your abstractions, right? It should depend on your business logic layer. That's where those abstractions should live. And so it's inverting that dependency, and it's making it so it's going to be much more loosely coupled. And now you can swap in and out different implementations for things. So that's sort of a long answer, but hopefully that helps.
So I think for people who haven't really gotten into that, for myself, not that I'm not into it, but I'm just thinking, one way to the dependency inversion, I think whenever you see, for example, in business logic code that you're maybe doing a database call, or if you see SQL in, let's say, you're next to your business logic, that's probably a good sign that you're not right. Abstracting that database logic some away.
Yep. There's a principle called separation of concerns that I know you've heard of that would apply there.
Yeah. So probably one of the biggest benefits is, for example, the business, having the business logic and the database logic separated. And then, for example, your database logic, if you're able to, you can maybe put an interface on top of that. And that would let you basically test your business logic, but not have to make database calls, which I think is one of the big benefits.
Yep, exactly.
You can actually test your code with, I think you had mentioned this, you can test it without having to rely on actually sending emails or actually querying your database, which, the benefits are you can write tests that are smaller and then they run faster. So there's lots of benefits there. How about you, Derek? What do you think?
I just want to go back to kind of the original question, maybe phrase it a different way, or when you said heuristics about kind of the things that you're seeing, is it really come down to pain points? Is there certain pain points that people know they're having that are a dead giveaway? I think is it I'm having trouble testing. I have this class that has 10 different dependencies, and this is becoming difficult to mock. What are the probably see where I'm leading this, but what are some of the pain points that people realize, okay, there's something up here?
I like that you use the word pain, because one of the things I talk about a lot in my presentations and courses is pain-driven development. And
Yeah.
so like when I talk about design patterns and people want to go off and just use them all at once, it's like, no, wait until you're experiencing the pain that this thing is meant to address, and then you know how to apply it now. So if it's causing you pain, then you can address it with some kind of a refactoring. And so yeah, some of the things would be like, this is really hard to test, or this is very tightly coupled code, and I'm having trouble extending it the way I would like. There's a nice tool that I use quite a bit called NDepend, and there's other similar tools like SonarQube that will let you analyze your code using what's called static code analysis. And it will look for things that are good heuristics for quality checks. So some of the things it might check are how many lines of code are in a class or in a method, which you can kind of eyeball yourself, but it will let you like run queries against all your code and find the biggest method. An even better heuristic is what's the cyclomatic complexity of a method. So you can go and check and see how many different pathways through all the if and conditional statements inside that method are there. And ideally, you want that to be under 10, is a pretty widely accepted heuristic for methods. Occasionally, some things will be higher, and it's fine if it's like a configuration method and it's just setting up a bunch of automapper rules or something like that. Sometimes those have a high cyclomatic complexity, even though they're really simple to understand. But if it's like business logic, and you've got business logic method that's 200 lines long and has a cyclomatic complexity of 50, good luck maintaining that, right? So it's an easy one that you can run a tool against, and it'll highlight where are the worst offenders. I have another similar rule called aggregate complexity that you can run against your entire project. The problem with cyclomatic complexity is it's only relevant to a given method. It doesn't tell me anything if you say, oh, my solution has a cyclomatic complexity of 300. Is that good? Like, I don't know. It depends on what your solution's doing, right? It could be fine. But if your aggregate complexity is more than 0, then that tells me that you've got some methods that are too complex. And basically all the aggregate complexity measure does is it does a check on every single method, and then it divides by 10 and drops fractions, and that's the number, right? So if all of your methods are under 10, you'll have a 0. And I've got a rule that you can plug into NDepend or even just run as a standalone utility on my blog. So those are some of the things that I will use with customer code. I'm doing a code review or assessment to kind of see like where are the worst spots in terms of code quality, and some of there's usually associated pain, right? Like when I run this thing, I haven't even talked to the development team yet, but somebody gave me access to the source code, and then I come back and I say, so tell me about these methods here. Have a line count of over 500 and a cyclomatic complexity of something crazy, right? They're all like, oh yeah, we don't touch those.
I think most people know exactly what you're talking about if they've been in the industry for a few years at least. I think I've actually seen one project I worked on, a class with the cyclomatic, or there was a method with a cyclomatic complexity of it was like 700 or something. Like it was.
Oh wow! I was gonna say I think my record's about 350. So
yeah, it was. I don't remember how large this one method was. It was thousands of lines, and it was just a huge switch, like nested switch case statements. Right. Yeah. Anyways,
and
good luck with that.
Right. It's like they probably didn't need any other methods in their whole program. Right? They could do it all.
Pretty much, yeah. So I think we're coming around to the end. I do want to point out, even for people who are maybe starting out, when personally when I started getting more into architecture and design, like intentionally trying to learn about it, one of the things that helped the most is I first discovered domain-driven design. Now we don't really have to talk too much about it. At that time, I watched Steve's course on Pluralsight, and I think it's called The Fundamentals of Domain-Driven Design.
Yeah, DDD Fundamentals with Julie Lerman.
Okay, yeah, that's the one. I would recommend that to anybody who's interested in design, period. I think that is just kind of a solid way to get your head around some of these concepts, and I think DDD in general is a good approach anyways. So maybe you just want to talk about that briefly. I know we probably have a few more minutes.
Sure. Yeah. So domain-driven design's been around since the book came out in 2003 or 2004, if I remember right. It's definitely grown in popularity now, and it applies quite a bit to larger, more complicated systems. So, if you're doing microservices or you're contemplating doing microservices, you'll seem to hear a lot of overlap with domain-driven design principles because they can help quite a bit in that type of architecture. The architecture that domain-driven design wants to use is essentially what we would today call clean architecture, and at the time I think it was called hexagonal architecture or ports and adapters. And it's basically one that uses the inverted dependencies that Solid suggests or recommends. And so if you put all of your infrastructure concerns and you kind of keep them at arm's length from your business software, then it makes it much easier for you to deal with that complexity. Some of the things that domain-driven design has in it are ways for you to collaborate with the customer, and things like how you map customer concerns to actual models inside your software, what kind of terms and language you use, and so there's a big part of it that's central to how you communicate, and it's in that way it's sort of an agile software development, I won't say framework, but methodology, let's say. But then on the more technical side of things, it has a bunch of really useful patterns. And some of those patterns folks use whether they're using DDD or not. Things like entities and even repositories are extremely common, and most developers are using them even if they don't know it. And then others are not quite as well known outside of domain-driven design. So things like domain events are a great way to decouple some of the things that happen inside your domain model, inside your business logic. And another one of my favorites that almost nobody is using is specifications, which are a way to take common queries and encapsulate those in well-named and testable classes to make it so that your code is a little bit more well-factored. So that's my brief spiel on DDD, I guess.
Cool. I appreciate you doing this. If there's anything else that you want to, I guess, how to reach you, you're obviously on Twitter. So have your podcast as well. So
sure. So you can find me on Twitter. Ardalis is what I go by pretty much everywhere because my name is Steve Smith and there's a bazillion Steve Smiths. So usually if I can get the name Ardalis, that's what I'll be. I do have a podcast of my own. It's called Weekly Dev Tips. You can find it on weeklydevtips.com. And it's short, 5 or 10 minute long tips with me or a guest, theoretically every week, although I've been known to skip a few. And then two last things for your listeners to check out if they're thinking about how to keep things loosely coupled. Do a Google search for New is Glue, which is an article I wrote a while back that talks about one of the biggest ways you couple things in your code. And then also the explicit dependencies principle, which is not one of the solid principles, but could be, that talks about how to make sure your classes are being explicit about the things that they need in order to do their job.
We hope you enjoyed this episode of the Loosely Coupled Show. If you did, please subscribe for more on software architecture and design.